Welcome back. I'm Mike from Golioth, and today we're going to look at uploading large sets of data from constrained devices to the cloud. One good way to illustrate this is uploading an image, which they tend to be tens or hundreds of kilobytes large, and that can be difficult from an IoT device. And so let's just jump right into the demo today. I have a serial terminal here, and we see that the device I'm using, which is an NRF9160 cell modem, is connected up and waiting for us to take a picture. So if I just go ahead and click the button while smiling, we can see we're immediately uploading blocks. I'm going to make my text just a little bit smaller so we can see the side of that. Let's see, there it is. All right, so you can see blocks remaining. It's going down. These blocks that it's uploading are 1024 bytes, so 1 kilobyte in size, and it says that it's been successful. So I'm actually going to go over to our Amazon S3 bucket. We have nothing in there right now, but if I refresh it, we can see that there is something in it now, and I'm going to download that and open it up. And we end up with a picture of me. All right, so that was a lot of fun. The device that we're using this from is this right here. So it's just an NRF9160. This happens to be an ArduCam, which was nice to work with in this case because it has its own internal RAM where it caches the image, so I can just read from that. But what we're really talking about today is the ability to do block uploads with devices. And so I can go over to the Golioth console here. You can see here's the device that I was just connecting with. But I have a pipeline in here, and what pipelines do is they tell the server where to route the data that's coming in through the stream service with Golioth. And so right here I have an image to S3 pipeline, and it's basically saying, all right, anything that comes in on the path file upload and is binary, so octet stream, I want you to take that and set the destination to Amazon S3. The parameters here are they have to do with your bucket setting on Amazon. So you'll need to have the name of the bucket and then an access key and an access secret. And those you don't put into your pipeline, you put them over here in credentials under secrets. And they get stored here, and once they're stored, you can't read them back. So that's a nice little security feature there. The demo that I just showed you came from Golioth's AI Summer. And so one of the things that we thought about is what if you have a company that is working on image recognition and some of the devices are failing to recognize what's in the frame, and you want to say, okay, well, what is that? How can I send that back up to the cloud and then use that when I train the next set? And so this image upload example is open source and available for anyone to use. It is based on this ArduCam Mega, which you can pick up yourself and connect it to any of these three devices that we're supporting right now, which is the 9160, the ESP32, that would be Wi-Fi, and the NXP 1024, which would be an Ethernet board. However, in this example, there is also the ability to upload a file without having the camera connected. So let's head over and take a look at just the main from that file, because I would like to walk through kind of how that is working. There is also a companion blog post that goes along with this that you can look at. And so in the case of the camera, it's nice that the camera has internal memory. And so what I'm actually going to do right here, I have a function from the camera library to capture an image, and I just give it a pointer to the camera module. So if you had several different cameras, you could change the pointers there. And that stores the picture. It captures the image. And then I want to send the image up to Golioth, so I can use that pipeline that we set up. And here's the function call for that. It's the Golioth stream set blockwise sync. And so looking at what's in here, so we always have a client when we're calling Golioth APIs, because that tells the SDK where to connect to and how to authenticate. You remember that I set up the pipeline to look for the path for file upload. So here's where I'm telling it the path that we're sending this to. This one right here is the octet stream. It's telling the type of data that we're sending up, in this case binary data, as opposed to like JSON or CBOR. And then I set a callback here. So this callback is something that you will write for your own needs. We'll take a look for that in just a minute. The final one is a user argument. And in this case, I'm sending a pointer to the camera itself because I'm going to read from the memory of the camera. And so let's go and take a look at how this callback works. So with the callback, we're going to get these parameters. We'll get a block ID. So it says, all right, in our example, we were sending blocks of 1024 bytes. And so it's going to say, if you have block 0, that means start from 0 and send 1024 bytes. If it says block 1, then you start from 1024 and send 1024 bytes, and so on and so forth. In order to send them, you're supplied with a pointer to a buffer, and that's where you copy the memory for the data that you're uploading. There's then a block size. Ours is 1024. These block sizes are set to CoAP sizes, which is what Golioth is based on. And 1024 is the largest CoAP size. The server could suggest smaller, and you can configure smaller sizes with the Golioth SDK, but generally that works really well. IsLast is a flag that you set if you're sending the last byte of data, so when you run out. And then finally is that user argument right there. So this is the callback. Once we've told Golioth we want to upload an image, then the SDK is going to call this and say, hey, give me the data that you want to upload. I have up here some error checking. I'm not going to look at that right now, but this just basically calls this function, which reads directly from the camera, and then goes ahead and returns a 0, return a Golioth OK to tell Golioth that the data is ready to be read. Because this is specialized, I'm actually going to show you a separate callback that we have for sending a data file. So you can just comment out the initialization for the camera if you don't have the camera, and then use the other button in order to send the file itself. So very similar, you'll see this block upload read chunk is a callback that we just looked through all of these parameters before. In this one, what I'm actually going to do is set the maximum block size from the block size that was passed in. And we're going to check that later to see if we're at the end of our data read. So I'll come back to that in a second. The other one is this is pulling in an argument. This time the argument is a struct that contains a pointer to a header file and a size for that header file. And the reason I abstracted this is because you could use the same callback for different data structures. You just have to send a pointer in the length in order to do that. And then we have here a calculation of the offset. So if you're at block 0, 0 times the block size, 1024 is 0, you start reading from your source data at 0. But if you're at block 10 and the size is 1024, you're going to read at 10,240. So this just tells the function, hey, where do I start reading my source data? And then finally, we calculate the total length of the source file minus the offset. And so what that'll do is if that number is too large for the block size, we know we're not on the last block. And so that's actually the thing that we're going to check. There's some error checking here, but right here. So we take the block size that we calculated, and we check to see if it's less than or equal to the max block size at the beginning. And if it is less than or equal to, it tells us that we're going to run out of data after this. So we don't want to do, or if we run out of data after this, we don't want to call this callback again. We want to say this is the last one. So the way we do that is we reset that block size, which is given to us as 1024. Let's say we have 100 bytes left. We reset that block size here, and then we set this flag IsLast to true, which says to the Golioth SDK, hey, this is the last block that I have to send to you. Otherwise, we're just going to go with the block size as we had it, and we're going to make sure IsLast is false. And then it's just a memory copy. So remember, we're given this block buffer right here. So we're going to copy into the block buffer. And then we want to take the beginning. So this is a pointer to the beginning of our header. And we want to offset it by the offset that we calculated. And then we want to copy this many bytes. So for every byte except for the last one, this is going to be 1024, whatever the block size is. For the last one, we're going to have reset that right here to the block size, and so it's only going to copy that many. And then the important thing is to send a Golioth OK, which tells the SDK, hey, I successfully copied my data into that buffer, so you can send it off to the cloud now, and everything else gets taken care of for you. If there is a problem somewhere along the way, you can send an error code, and that's going to let the SDK know that there was a problem with sending this, and so we're all done. It might seem a little convoluted the first time you've seen it, but like I said, we do have this example up and available for you to use. So go and check that out. There's a couple of different ways that we're sending data there. And we'd love to hear what you are using the block upload for and things that you need for your constrained device fleet. So you can always go to the Golioth forums and check that out. All right, it's good to see you. I'll meet you here for the next one.